Hello and welcome back to Zig's Math Lessons. Today, derivatives of composite functions. Definition of a composite function. There are two functions, f of x and g of x. The composition of these two functions could be h of x, where h of x is f of g of x. What's happening is g of x is being subbed into f at the input part. If you see f circle g of x, what that means is f circle g of x just means f of g of x. I actually think the little circle means of. F of g of x. Here's an example. Given f of x, some linear function, and g of x, some quadratic function, determine an equation for f circle g of x. So what we'll do is we'll take g of x and plug it into f. F circle g of x is f of g of x, so we'll take the f structure here and into it we'll substitute g of x. So it'll be 2 times g of x plus 5. And then plug in g of x using brackets and simplify. Now an equation for g circle f of x, this means g of f of x. So we'll take f of x and plug it into g. We'll look at the g structure, which is something squared plus 4. And into that we'll substitute f of x. So g of f of x is something squared plus 4, and the something is f of x. And so we'll plug that in, and we'll do the math and simplify. Taking for granted that you can simplify expressions. Moving on. The chain rule for differentiating composite functions. If y equals f of g of x, in other words, y is a composition of a couple of functions, then y prime is equal to f prime of g of x times g prime of x. You really got to get that memorized down. It's the derivative with respect to a function times the derivative of that function. With examples, it might become more clear. In Leibniz notation, if y is a function of u and u is a function of x, in other words, we don't have an equation with a y in it and an x in it. We have a y with a u and we have a u with an x. We can still make a link between y and x, using u as a link in the chain, hence the chain rule. dy by dx equals dy by du times du by dx. Notice how these du's could cancel, since these are fractions, and we're multiplying fractions. The du's could cancel, and we would have dy by dx equals, well, obviously dy by dx. So we're kind of using u as a link in the chain between y and x. So let's take a look at this a little closely. dy by dx clearly equals dy by dx, that's obvious. But we could slide the dx over, and we could put anything here we wanted to, because it's going to cancel because we're multiplying fractions. So I could put a smiley face up there and a smiley face down there, and they would cancel, and of course we'd be back to this. But what we do is we put a variable in there, like this. So we put a du there, and we've made a link in the chain between y and x. And there's no limit to how many links that we can put into this chain. We can put another link in just by sliding x over, and we could put our 2 dots here, and as long as we put the same thing at those 2 dots, it's a true statement because they would cancel and we'd be back to this statement. And what we could do is put another variable in there, like dv, for example. So dy by dx equals dy by du times du by dv times dv by dx. And you can see it's true because if you cancel the dv's and cancel the du's, you'd have dy by dx equals dy by dx. Example, differentiate. H of x is, looks like a cubic to the 5th. All right. Solution. Consider this to be a composite function. H of x is f of g of x, where f of x is something to the 5. So this is something to the 5, so f of x is x to the 5, and g of x is the something. So what we've done is we've taken g of x and plugged it right in here, and we're getting f of g of x, f of g of x. And we know that this means we'll have to go f prime of g of x times g prime of x when we differentiate. F prime of g of x times g prime of x. Now what this f prime of g of x means is differentiate with respect to, not a variable, but with respect to a function. So we'll have to go 5 times the function to the 4. 5 times the function to the 4 times the derivative of the function. Now I've laid it out here like this because I wanted you to see that h of x is actually g of x to the 5. So we'll go 5 times that function to the 4 times the derivative of the function. This is fairly easy to do because we just replaced g of x with, well, what it is. And g prime of x is easy to get because it's 3x squared minus 4x plus 1. The chain rule and the power of the function rule are instances of each other. Moving on to a Leibniz type example. U is a function of x and v is a function of u. Find dv by dx. So we don't have an equation with a v in it and an x in it. We have a u with an x, we have a v with a u, but we want the derivative of v with respect to x. Now, it is, of course, possible to take x squared plus x, which is actually u, and plug it in here. Yeah, you could. But the point is, we're trying to learn how to use this chain rule. So let's do it using the chain rule. Solution. Well, we need a link in a chain between v and x. So dv by dx equals dv by du times du by dx. Checking our work here, these would cancel. And now we've made this chain between v and x. dv by du is easy to do. It's just 1/2 u to the minus 1/2 times du by dx is 2x plus 1. And we see that on the bottom here we've got a 2, and u turns up on the bottom under a root sign. Kind of like that. And the 2x plus 1 will go into the numerator, and u will become what it actually is, x squared plus x. And we have dv by dx. It's 2x plus 1 over 2 times root x squared plus x. Please don't cancel these 2's. They don't cancel. That would be basic algebra. Moving on, let's do it again for practice. Y is a function of u is a function of x. Find dy by dx, using u as a link. Solution, dy by dx equals dy by du times du by dx. And dy by du is really easy. It's 3u squared. And du by dx is really easy. It's 2. So that makes 6u squared. Now here we can say, well, u is actually 2x plus 1. And this becomes this. And I am going to take for granted that you can do that accurately. And I suggest you take a piece of paper and actually do it. And make sure that this is what you get. Moving on, let's go again. Another practice example. U is a function of x. V is a function of u. Find dv by dx when x equals 4. That's what this says. Find dv by dx when x equals 4. Okay, so we look for an equation with a v in it and an x in it. I don't see an equation with a v in it and an x in it, so I'm going to need the chain rule. dv by dx is dv by du times du by dx. And so we've used u as a link. dv by du, well, dv by du. That looks like a quotient. So within this chain rule, I'm going to have to do a quotient rule right here when I go dv by du. Top thing prime times the bottom thing minus the bottom thing prime, which is 1 times the top thing over the bottom thing squared. Let's check. top thing prime, which is 1 times the bottom thing. Okay, minus the bottom thing prime, which is 1 times the top thing. So I didn't put brackets, but I didn't need to. So what you're looking at right here is this v differentiated. Top thing prime, which is 1 times the bottom thing. There is that. Minus the bottom thing prime, which is 1 times the top thing. There's that. Over the bottom thing squared. Times du by dx. Well, this is x to the 1/2, so we'll say 1/2 x to the minus 1/2. Now these u's offset. We're left with a -1 in the numerator. We're left with a 2 in the denominator and a root x in the denominator as well. And now u is actually root x, so we could put a root x here. And we'd be doing well. At this point in time, we have our dv by dx. There it is. We want to evaluate this when x equals 4. Some of the work is mental. Root 4 is 2. 2 times 2 is 4. And root 4 is 2. 2 minus 1 is 1. That's why this says 1 squared. Root 4 is 2, and 2 times 2 is 4. That's why that says 4. And simplify the expression. We have -1/4. And a last example. U is a function of x. V is a function of u. W is a function of v. Find dw by dx. So we're going to have to build links between w and x, because I don't have an equation with a w and an x in it. So, solution. We have to build the chain between w and x. dw by dx equals dw by dv, because I can do that, times dv by du, I can do that, dv by du, times du by dx, I can do that because I have these. Notice dv's could cancel, du's could cancel, and we would have dw by dx, which would make sense. So at least the statement is solid. And now I've rewritten, I rewrote v as u plus 1 to the -1 because we have to find dv by du, and this is easier to differentiate. Doing the differentiating now, dw by dv will be 1/2 v to the -1/2 times dv by du, which we're looking here, dv by du is -1 u plus 1 to the -2, times the derivative in there, which is 1, but I didn't mention that, times du by dx, which of course is 2x. Simplifying. When we simplify, this is a lot of the work is done mentally in math. I mean, you can go crazy writing everything down. The 2 on the denominator cancels with the 2 in the numerator. They vaporize, they're gone. Root v will show up in the denominator. An x with a negative sign will show up in the numerator. And u plus 1 squared will show up in the denominator. Let's see this. So the 2's canceled. The v is in the denominator because there's a negative exponent under a root sign. U plus 1 squared is in the denominator because of the negative exponent. X is still in the numerator, and there's still this negative sign that has to be accounted for. So this to this is what math people do. And I suggest you dwell on that a bit until you too can do it. Now, observe. dw by dx, we want an expression with just x in it. The problem is that this expression has a v and a u in it. So we have to swap them out for x's. So let's reference these equations and swap them out. The u will obviously be x squared. That's no problem. The v, well, here it is here. It's u plus 1. Let's start with that. Well, root v will be this to the 1/2 because this says root v. root of this is this expression to the 1/2, which is u plus 1 to the negative 1, but to the 1/2, so u plus 1 to the negative 1/2. And the numerator I copied, and the denominator, the rest of the denominator I simply copied. Now we have these multiplying powers of the same base, keep the base and add the exponents. So we could say negative 1/2 plus 2 is, well, 3/2, and the u is x squared. So we could just plug that in like that. X squared plus 1 to the 3/2 with a negative out front and an x. So now we have dw by dx with just x. Other individuals would like to see this u plus 1 in the numerator because of the minus exponent here, the negative exponent, and under a root sign. So other individuals would consider this better, because now this person doesn't have the fractional exponent. I have a fraction here. Other individuals would like to see this radical boosted to the numerator like that. Both are correct. If you like the presentation, then please subscribe and tell your friends and help me grow my channel. I really appreciate it. Thanks for watching. Have a good day.